Okay, everyone, this is for notes for 1.3 factoring, and this is going to be video 1 of 3. So the first thing we're going to talk about, what are the general guidelines when it comes to factoring. We have 4 things that we do. The first one is the greatest common factor, and that's just when we pull out the GCF of all terms. The second one is when you have 2 terms, you're going to either do the difference of squares, or you may have the sum or the difference of cubes. So remember from 1.2, you had to memorize a lot of what cubes were. Most of the time we know the squares. The third one is when you have 3 terms, that's when you're going to do trinomial. So when you have a trinomial factoring, oops, let me put an I in here. And that is when we do trial and error. And I'm going to do a separate video for that. Okay? And then the last one we're going to do is grouping. And I think within the grouping, we'll be talking about when you factor everything. Okay, so let's start with the first one, the greatest common factor. Okay, when you have the greatest common factor, you're going to find all GCF, find GCF of all terms, and then divide out GCF of each term. Okay. So we look at the first one. You can probably do this. I like to say, I first look and I'm going to state what the GCF is. The GCF between the numbers on here, between 10, 5, and 20, is a 5. And I look at the variables a to the 7th, a to the 4th, and a squared. And the most that I can take out between those terms is, for the variables, is a squared. And what I normally do is I divide each fraction, because I like to divide out the GCF. So I kind of show it as in fraction form, because sometimes you can see better what you're reducing when you're dividing out a fraction. So it's still division, because it's in fraction. Fraction bar means division. So if 10 divided by 5 is going to make this a 2. Cancels to a 2. Now I have a to the 7th over a squared. That means the rule is I can subtract the exponents, and I'm left 7 minus 2 is a to the 5th. Okay. And then plus 5's cancel. A to the 4th minus a squared is a 2. That minus comes here. 20 divided by 5 is 4. And then the a's just cancel out. Now the only thing I got to make sure is that when I'm here, I have to put that GCF in the front, because you want to be able to distribute back in and get the answer that the equation that you started with. Okay. Letter B. All right. When we're dealing with fractions right here, exponents, you want to, again, like we always do, we pull out what we can. And the only thing that's this one is you're going to pull out the smallest thing you can when it comes to the variables. Well, 1/2 is less than 2 and less than 3/2. But just a overall rule, when you have for fractional exponents, just use the smallest. Okay, we're talking about the exponents. So the smallest exponent for us is a 1/2. So again, I'm going to divide everything by y to the 1/2, y to the 1/2, y to the 1/2. So I have y to the half on the outside. So the rule tells me to subtract. So 2 minus 1/2. Okay, so if I see it, 2 minus 1/2 is really 1 and 1/2. But we don't use it in mixed number. We got to change it improper. So that's going to leave us to y to the 3/2. Multiply the 2 to the 1 and add the 1 in that numerator. And there's your improper fraction. The second one, subtract again. So 3/2 minus 1/2 is 2 over 2, which is just 1. So I just have y to the first power. I'm not going to put the 1 up there, but it's an understood 1. The last one, you can do two ways and think about it. If I have y to the 1, so I have 1/2 minus 1/2 is 0. And if I have y to the 0, that just equals 1. So this should be a 1. You have to have a placeholder. Your has 3 terms up here. There should be 3 terms in here for this type of problem. Also think about when you distribute back this 1/2 into this, back into this parentheses here, it has to come out to what you originally started with. The other thing I want you to think about is when you look at, I'm going to write this right here again. When you look at this, and just look at this part, anything over itself is 1. Y to the 1/2 is the same as this y to 1/2, so that's why it can also be 1. So there's your final answer. All right, let's try the next one. I'll really look at what do you have in common. Do I have a GCF? Okay, I want to take what I have in common. When I look at these two, I definitely have this. I'm going to just highlight this. Even though it's in parentheses and it has a minus, a sign in there, it doesn't matter. It's being everything. A factor means something that I multiply together. I'm multiplying the times the 2 to the x, and then this parentheses x minus 7. So that's a GCF. That's a greatest common factor. Okay, now look at the numbers too. So if I look at the numbers between 2 and 6, I can pull out a 2. So my GCF is 2 times x minus y. And again, when I have to put this here, and it has to be in parentheses. There's my GCF. So if I divide everything by 2x minus y, and if I do this step, if you do this step, I promise, if you're having a hard time seeing what I'm going to factor out, you can see over top, oh, I can cancel. Yes, you can cancel this with this. You can cancel the 2 and the 2. And what's left over? Well, it goes in parentheses, an x. I can cancel this and this. Those always cancel to 1s. But I have a 6 divided by 2. That's going to give me a 3. And I have a y. There's a plus sign that goes here. So plus 3y. And that's done. If you were to distribute that back together, you would see that that would work. Okay? All right. That was the greatest common factor. All right. The next one we're going to do is when we have 2 terms. 2 terms, there's 2 cases that we have, or 2 types, cubes and difference of cubes, and difference in sum and difference of cubes, and difference of squares. So let's do the difference of squares first. Move my thing up here so I can see really good. Okay. You have to memorize this formula, like I said in class. You're going to need to make sure that you memorize these formulas. You're not given them. So the difference of squares that we have is that when I have a squared minus b squared, okay, I'm going to take the square root of a and the square root of b, and that's just going to be a minus b, and then a plus b. And every time you want to do these, if you want to check your work, you can FOIL it back out and see do you get what you started with. So in here, every time I do this, I'm going to tell myself what is a and what is b, because it's that order. The a is minus the b, okay? So if I take the square root of x squared, that's just going to be x. And if I take the square root of 121, that is going to be 11. Okay, so now I just have x minus 11. There's my a minus b. And then there's my x plus 11. And that's my a plus b. And just FYI, you can write it this way as well. It doesn't matter which one comes first because we're multiplying. Commuted property multiplication. And there we have this. Okay. Okay. Let's look at this next one. Same idea, but the thing is that you don't want to I know a squared is first, but we don't rearrange it to make a first. Remember, these up here are just variables. It doesn't matter what the order they're in. It doesn't matter if it's an A or a B. It could be an X and Y, P or Q. Remember, they just have to be a squared is first, and you're subtracting a b squared, okay? So here, when I look at these two problems that I have, this next problem I have here, I have a squared minus b squared. So I'll write that up just so we see it. So for me, well, what's the square root of 36 is 6. And b is the square root of a squared, which is equal to a, okay? Okay, so let's just use our formula now to write the factor form. So if I have a minus b, well, a is 6, and b for us is a, and the other one has to be the opposite sign, 6 plus a. Again, don't rearrange it to where a squared is first. It's what it is, what you see like it. All right, the next one, you probably don't, sometimes like this from here, I can see from this one and this one. You may not even have to worry about, oh, I got to write my A and my B. You don't. And again, remember, these are your notes, and there are times that I will write something that that you necessarily don't have to use, especially some of y'all who do understand it right away or remember it from before, and you don't have to do that extra step if you don't need to. Just use it to help you. So P and Q, so I'm just going to do P minus Q and P plus Q. Just note, if you have capital letters, you're given capital letters, you must use capital letters. Okay? All right, letter D is just slightly different. Again, I'm just looking at, do I have a difference of squares? This is a squared. I'm going to write it again like I did this one. So this one right here is a squared minus my b squared. So I do have a difference of squares. Doesn't matter because all this inside here is in parentheses. And so it's all being squared. So it's a square. It's a perfect square. So if I want just a, and I'm going to put this in parentheses, I need a plus b. For the b part, if I want to take the square root of b squared, then it's going to be leaving me with just x plus y. Okay? So I'm going to still use the idea of a minus b, a times b. So just be careful when you're with your parentheses and all this. So my first parentheses, and I'm just going to look at the a minus b part, is going to be, I'll put it in this, a, which is a plus b. Okay? Okay. So I have a plus b, and that's going to be the a part. And then if you look at what I need to do, I'm going to subtract the b, which is this. So I'm going to subtract, so make sure there's a subtraction sign, x plus y. Please put those parentheses around those numbers. Excuse me, those letters. All right, so now I'm going to close that parentheses. I use brackets when I have a lot of parentheses. Then my next one is going to be a plus b. Well, a is a plus b, but I'm going to do a plus sign this time, and then plus my x plus y, which is my b for me. And that's it. That is all you can do. If you don't like brackets, you can use parentheses. I just like brackets when there's so many parentheses going on, okay? So again, for us from above, this is your a minus b times your a plus b. That's what you did. Okay. All right. Let's do one more for this section. And here we have 25x to the fourth minus 49y squared. Find the GCF, okay? Now, if you have a little kind of reminder that if you have this power here, and it's an even number, it is always a perfect square when we're talking about variables, okay? So just know that. So I know that since I have x to the fourth, I know that this part right here, this one is a perfect square. 25 is a perfect square, x to the fourth is a perfect square. So what I'm going to do is I'm just going to see what my perfect square is. And so let me see what a and b is. So here a is going, oops. A is going to be 5x squared, and then b will be 7y. So you just take that number and divide it by 2 because you're taking the difference of squares. All right, so now let's just write our two parentheses. 5x squared, and I'm going to do plus 7y. My second term is 5x squared minus 7y. Okay? All right. Okay, so we're on to the second part of two terms. If you're given two terms, you can have the difference of cubes or the sum of cubes. And so I'm going to fill in your formula, and I'm going to do it separately. So I'm going to do the sum first. So that is when you have a cubed plus b cubed. To factor that out, you're going to do a plus b. You're going to square a. You're going to subtract a times b. And then you're going to add b squared. Okay. Thing to kind of notice here is that when you look at this part right here, I'm starting this, I have a plus here, and it's a minus. Okay. So these first two are going to be the same, and then the other will change the opposite there. Okay. All right. When if I have a difference of cubes, excuse my handwriting, this is when I have a cubed minus b cubed. Okay. I'm going to rewrite that. I feel like that's very shoved in there. It's hard to see it. So I'm going to write underneath. Okay, so the difference is going to be a cubed minus b cubed, like that. Okay, so again, I'm still going to have the cube root of a minus the cube root of b. I'm still going to square a, but this time I'm going to add, and I'm going to multiply a times b, then I'm going to add b squared. Okay, so things to kind of notice that here this is minus and this is minus. So see, if I start with the minus, my first part's a minus, but then it's always the opposite. Okay, notice that this part right here is always squared. Excuse me, a positive. Okay, so the thing you have to look at this is what is the difference of cubes and sum of cubes? I got to find out. When I'm given two terms, do I have perfect cubes? So same thing as we did with the difference, we got to find that out. So right here I do have a perfect cube and a perfect cube. Okay, 27 is a perfect cube. So if I take the cube root of 27, so I'm going to call this b equals 3. Take the cube root of x cubed, a equals x. So I'm going to follow my formula. I'm going to write my formula out so I see it. You have to have these memorized, like I said in class. We do not give this to you in person. In person. You do not get to have these in person. Okay. So if I know that I have to have a and b here, so my first part will be, so x cubed plus 27. A is x and b is 3. Okay, now this one tells me to square a. Well, here's a. A squared is just x squared. The next time, if I minus, now it tells me I have to multiply a times b together. Well, here's a, here's b. Multiply together, I get 3x. And the last one tells me I have to square b. So here's b again. B is 3. 3 squared is 9. Okay. This part right here is not factorable. Okay. When you do the difference of cubes and you got down to that very bottom part, pretty basic, then that is not factorable. Okay. If you're just doing this. right, so that's our solution. All right, let's look at this next part. We have the next problem, letter B, 64a cubed minus 125m cubed. I'm looking at perfect cubes this time, so can I take the cube root of 64 and come out with a nice number that's got a decimal? Yes, so the cube root of 64 is 4. I know this is a cube because I got a 3 there. Is 125 a perfect cube? Yes, because the cube root of 125 is 5, because 5 times 5 times 5 gives me 125. And then this one right here is also a perfect cube. So for me, A is 4A. So cube root of 64 is 4. A cubed to cube root A cubed is A. For B, the cube root of 125 is 5. And the cube root of m cubed is just m. All right, this time instead of using the addition one, the sum one, I'm going to use the difference. So again, the a minus b is first because it's starting with difference. You're still going to square this, the first term in this next parentheses, but this time you're going to add a times b and still add b squared. Okay, so with what I have, just right here like I did up there, a minus b, so a minus b, so a is 4a and b is 5m. So subtract those two. You're going to square a. So remember over there, a is 4a, okay? If I square that, I'm going to get 16a squared. Okay? The next part tells me to multiply for a and b, so I'm going to multiply these two together. Okay, so that's going to just, the number will be 20. And then I just do a times n next to it. The next part, I need to square b. Well, b is 5m, and when you square that, you get 25m squared. And then you're done. Can't stress enough that you really need to make sure that you have these memorized. Okay, you will not be given any of the formulas for this. Okay.